Okay, we'll finish off going through short answer homework sheet 2. Question 3 was another normal distribution standard deviation question for us because I think this is a skill that we really need to practice. It says here that the weight of species of bird is approximately normally distributed with a mean of 71.5 grams and a standard deviation of 4.5 grams. It actually first of all wants us to find a z-score to begin with. So remember, if we're finding a z-score, my formula is the actual score minus the mean divided by the standard deviation. This bird has an actual score of 67.9. I then subtract away the mean. We can see straight away that the actual score is less than the mean, which means I should end up with a negative z-score, and I divide that then by the standard deviation. So 67.9 minus 71.5 over 4.5 gives me negative 0.8 as my z-score. So my answer mark is for that negative 0.8. It then wants me to use the 68, 95, 99.7% rule to estimate expected percentage of birds that weigh less than 67 grams. So I should I want the pen. I should quickly sketch the curve, and if I do sketch the curve, remember my mean is here is 71.5, and we're going to the smaller side, so I'm only going to draw my standard deviations out this way. Minus 4.5 on this gives me 67 here. So this is actually just wanting to know one standard deviation away, and less than that wants me to account for what percentage fits under here. Remember, we're just one standard deviation away. We know that 68% of the data fits in here, so that means 16% is out in the tail. So my answer there is just 16%. The last bit then wants to know the number of birds that weigh between 62.5 and 76.0 grams. So if I do fill in the rest of my table, rest of my diagram, this here would be 62.5 grams, and then this one standard deviation here would be 76 grams, because that's me adding on 62.5. So number that weigh between 62.5 and 76 then is actually all of this here, how many fit under there. Now we can clearly see that 68 is included, and if you remember from that diagram, this bit here is 13.5. So we have 81.5% of the data fits in there. But the question asks me for a number. So for me to work out a number, I have to do 81.5 over 100, and then times that by 200, and 81.5 over 100, end up getting 163 birds. So I have to give my answer as the number, which means it is 163. If I then go to question 4, because that's me done. Scatter plot below shows body density in kilograms per litre plotted against waist measurement for 200 men. Once again, EV, RV. Hope you've got the routine. I can see here that I've got a negative association happening. I'm sloping down from left to right, and it says when a least squares line is fitted to the scatter plot, we get the equation of the line body density RV equals 1.195 minus 0.001512 times waist, which is my EV. And the first thing I have to do is draw a graph of the least squares line on the scatter plot below. Now, what I want to point out to you, when you need to draw a graph, you need 2 points that fit on the line, and then you just need to plot those 2 points and connect the dots. If I look at my axes here, they have given us axes that span from 60 to 130. And when they are marking this, they're going to look at that line across that range of data. So 60 is a waist measurement and 130 is another waist measurement. What I recommend you do is you take those values and you substitute them into the rule. So first of all, we're going to find the body density when weight is 60. And that means I'm taking my rule and I'm doing 1.195 minus 0.00152 times 60. And so I get an answer of 1.104. What did it end with? 28. So this is telling me the predicted value with a waist measurement of 60 has a body density of 1.104. If I look up here, this is 1.10. These are all going up, then this would be 1.11. So this point of 1.104 is going to be like just in here. It's really hard to see that dot, sorry, but there we go. No, it doesn't want to stay. Sorry, I've got to make it big so it's going to fit. That's my first point. I need my second point to then draw the line. And remember I said I want to do that for 130 being the waist measurement. So if I'm going to do this over here for 130, I'm substituting that into my rule this time. So this time, body density is 1.195 minus 0.001512 times 130. And so again, in my calculator, I'm just going to copy the rule down and change that to be 130. So for reference sake, I highlighted that with my pen, drag and drop, and I can just copy. And I get the 0.9984. And I mean, really, you can think of that just being like exactly one if you like, because that's pretty close to 1. So that would be 130, and 1, if I track this across, is here. Now, you would then be doing this on paper. So you would take your ruler and you would then connect the dots. I'm just doing this by sight, so it's a bit dodgy, but your line would be much better. When they mark this, they're going to look at the start point, they're going to look at the end point, and there's probably a couple of points of reference on the graph that they're going to look at. To be honest with this one, I reckon they'd be checking like it hitting here, and I reckon they'd be checking how the line goes through there. I'm going to upload my handwritten solutions, so please have a look at how I've done it with a ruler by hand, and you can see like those points a bit clearer. Finally, it says that in this study, body density of a man with a waist measurement of 122, so this is a real person, actual data, was 0.995 kilograms per litre. So this is the actual EV and the actual RV. And it says show that when this is fitted, the residual is negative 0.02. Remember, for a residual, we have to do actual data minus predicted data. So we actually have to get the predicted body density for this man who has a waist measurement of 122. So I'm going to again follow the rule and substitute in. I'm doing 1.195 minus 0.001512 times 122, because that was this guy's waist measurement. And so on my calculator, again, I'm going to copy the rule. So I'll just highlight and drag and drop. And then I'm going to change this to be 122. And I get 1.010536. I'm going to write all of those down. That's my predicted value. To find the residual, I have to do actual minus predicted. You wouldn't have to write that part down. You could just go straight to substituting. So we would do 0.995 minus 1.010536. And again, if I do this in my calculator just to confirm, so that minus my previous answer, I get negative 0.0155, which does round to be negative 0.02. Now, this is only worth 1 mark, and it is a show that question. So I have to get this as my final answer. I can't use it, and I need to show how I got that as my answer, which means I do actually have to do this part here to get the predicted value, and then I have to show that being substituted in the rule to then show how this is found. So there's actually quite a few things I need to do there to get that 1 mark, but hopefully that makes sense for us. As before, please let me know if you have any more questions about this short answer homework sheet, and I hope that this video was helpful for you.